Good afternoon, everybody. I'm Francesco Sauro. I'm working for the ESA Pangaea team, and I will talk to you about the Pangaea training program, which is a training program from ESA about field geology and planetary geology. We have been running this training now since 7 years, and so the training has been developing through time. And now it is in a state-of-the-art, let's say, stage where we think we are providing very good learning opportunities for astronauts, for ESA, and also for other space agencies. So all of you that are working on lunar science know how it was important for the Apollo missions, the learning on the field, the field trips, especially for the J missions, so for the last 3 missions, to really gather new information from the lunar surface, for the astronauts to be able really to collect samples that are useful and that were fulfilling the requirements from the science community. So in ESA, we started in 2016, already thinking about future human exploration. We need time. Astronaut needs to be prepared, and this kind of knowledge needs time and practice to be acquired. And it's something that really happens, learning in the field, learning by doing. So, of course, it doesn't only involve astronauts. It's something that involves different, let's say, space-related sectors and partners, like, for example, of course, the scientists, the scientific community, training and operations, but also analog sites, places here on Earth, and especially in Europe, where we can train the astronauts in similar geological environments, of course, industry for tools and innovation and technologies. So after the beginning in 2016, as I said, now also we see this need also through the, as Leonardo was saying, NASA Artemis 3 Science Definition Team report. So all the astronauts that will go to the moon for sure needs to participate to courses, Apollo style, geology, planetary science, especially I would say in the field. And also they need to be ready to collect varieties, so also to discern between different samples and subsurface samples on the moon, or even in the future in other planets. So as I said, it's 7 years we are doing Pangaea, and we had up to now 5 editions. A new one will start in September. As you can see, we have several ESA astronauts. Since 2021, we have also the participation of one astronaut in the Artemis group, Kate Rubin, and last year, Stephanie Wilson. I want also to say that the training and the program started with the collaboration of CISAS here in Padova, and I want to remember the director at the time, Stefano De Bei. And it involves a very complex also logistics setting with Miles Beyond and Altec, and also we had the help of ALSI in providing fellowship on specific on this program. So there are instructors from the planetary geology community, European community, from Germany, France, Italy, Spain, UK, Norway. All the instructor and ESA, we published this paper on Acta Astronautica that basically describe the training. Of course, it was not the same every year. As I said, it was evolving through the years. So now this paper described the state of the art and the structure that we have now. All the program is managed by the space training team in the European Astronaut Center. So how it is now Pangaea, we bring the astronauts through a very complete training, which has the objective to prepare them not for a specific mission, but in general about to be ready on geological exploration on a natural environment which has similarities, analogies with the moon. So we go to 4 sites in Europe. As you see, 3 of them are geoparks. We go from the Dolomites to learn the basics of geology and also something about sedimentary geology and Mars. Then we go to the geopark of Ries, one of the best impact crater in the world in Germany. then Lanzarote for lunar and Martian volcanism, and then at the end, Lofoten in Norway for anorthosites and lunar highlands, a very spectacular place. So the cost structure is made through incremental learning, as we can see from this graph here. We start, of course, with theoretical lessons, but they are always accompanied by practical exercises and direct observation in the field after the lessons in the classroom. And the first 2 sessions are still, let's say, there is a lot of guidance from the instructors, but from Lanzarote and Lofoten, we, let's say, lose the astronauts more free, and we start the traverse process, really the exploration process. So there is very few time in classroom, but a lot of time in the field, and we ask them to really require to do exploration through traverse, geological exploration. At the end, we have 23 days of training, 51 hours of classroom, 25 hours of practical exercise, and 60 hours of field trip and traverses. At the end, the objective is that the astronaut will be ready, let's say, to be involved in more specific training in the future, which will be probably related to mission-specific activities, and depending on the future mission, where it will be landing site, which will be the scientific objective. But it's the basic, let's say, knowledge that allows them to be ready and to focus on the specific objectives. The strategy is taking as a heritage a lot of lessons learned from Apollo, from the Apollo field excursions and trips and teaching. So of course there is a knowledge transfer process where we have instructor teaching to the astronauts how to, for example, recognize rocks, how to read the environment, how to describe the environment, how to document, take samples. So this is, we teach them and they learn from the experience from the others. But then the most important thing is the problem-oriented phase, where we discuss with the astronauts about science requirements, science objectives, science questions, and then they have to perform the traverse. They have to find out and discover, be ready for discovery, also for unexpected discovery, and so be flexible and to interact with the scientists in a proper way. So this is the part that the astronauts, of course, like the most, because it's really for them to go in the field and explore. So this is, let's say, the core of Pangaea. We do several self-directed traverses in Lanzarote. We do also in Lofoten. Sometimes we have real scientific objectives, so we involve scientists from the site that need some samples. They need some specific research to be done, and the astronauts are involved in this research because it is a very good motivation, and we are doing something that is real, 100%, and so they feel the need to really fulfill their objectives. So I wanted to highlight that already in Apollo, and this is an heritage from Harrison Smith and Jim Head, Professor Jim Head, the T3 concept. So the best way to teach an astronaut is to train him, then trust him, and then turn him loose. Because it's what we do also as geologists when we go, we explore, we have to be kind of loose and to be ready to the unexpected and to find what we are searching for, but also what could be completely new. I don't know if there could be any space debris from ancient civilization. That would be also nice, but let's say that there could be always surprises. So we have to be ready. In addition, of course, it's different from the Apollo times because we can add much more technology. And this was already shown by Leonardo. We can try to add to these kind of trainings technology that could mimic, or let's say, help to advance what could be the technology that we could bring on the moon in order to enhance geological exploration, to be able to identify different samples that look the same, but maybe from a chemical point of view are different, and to acquire documentation in a structured way, to have microscopes and so on. So this is something that we are trying to integrate in the training. As a conclusion, there are some lessons learned from this training. We just published them in this paper in Act Astronautics, but basically it's fundamental to have the astronaut going to the field and to interweave what they learn in the classroom with what they can see directly in the field. Because the perspective also from space, they can learn that the perspective of looking from a satellite images than to be there is completely different. There is a lot that changes, and so we have to be ready to read the environment. We have to be practical, implementable knowledge over pure theory. This was something already discussed during Apollo. Of course, elements of planetary surface exploration, scientific realism, the T3 concept is very important. And of course, we can add technology to this kind of training, so we can test technologies, but we have to be very careful that operational simulation should not overcome the field geology learning. The operations will come later when there will be mission-specific scenarios. So, and the other very important thing that is for the overall community, we need to develop a common language among the astronauts, scientists, engineers, operational planners, because sometimes we speak very different languages and we have to arrive in this mission with a language that is shared among everybody and is more effective in order to face discoveries on lunar surfaces. Thank you very much.